Joshua is working on the division problem 6/7 divided by 2/7. He says, well, 6 divided by 2 is 3, and 7 divided by 7 is 1, so the answer is going to be 3/1, which is 3. Do I agree or disagree with Joshua? I absolutely agree with Joshua. 6/7 divided by 2/7. Well, let's see what that actually means by using Cuisinart rods. And if I have 6/7, so that's going to be represented by, if I take the 7th block, so that's going to be my unit, and I put the 6/7 right below it. So this tells me that this green bar is 6/7 of my black bar. And I want to divide that by 2/7. So if I come over here and I get my 2 bar, this 2 would represent 2/7, right? Because I have 2 out of a total of 7. And I can put that right below the green bar. So I want to see how many of these 2/7 will fit into the 6/7. And I can see that the answer there is 3. So Joshua is not wrong by using this technique. And this technique works really nicely on this problem because 7/7 is 1. And this notation, we could always use this by finding the common denominator. So this technique will get us there by finding the common denominator. But if we look at a fraction that it's not as convenient, let's look at 2/7 divided by 1/2. I use Joshua's method. I have 2 divided by 1 divided by 7/2. Well, that would be 2 divided by 7/2. Really 2/1, right, if I want to keep looking like a fraction. Well, I don't know what that is, so I could keep going with Josh's method and say, well, that's going to be 2 divided by 7/1 divided by 2, right? So that's 2/7 divided by 1/2, which actually gives me this, right? I would have 2/1 divided by 7/2. So with Josh's method, I could be doing this all day, never get a nice fraction for my answer. Now I could manipulate the problem and say, okay, well, 2/7, I can multiply top and bottom by 2, divided by 1/2, multiply here, top and bottom by 7. Anytime I multiply a fraction, top and bottom by the same thing, I'm really just multiplying by 1, which doesn't change the fraction. So here I have 4 out of 14 divided by 7 out of 14, which I could use Josh's method. 7 divided by 4 divided over 14 divided by 14. And this was the nice case that 14 divided by 14 turned out to be 1. And my answer is 7/4. And we can take this one step further and kind of come up with a formula. If I have a fraction a/b divided by c/d, I could always find the common denominator by multiplying the first fraction by the top and bottom of the second fraction's denominator. And I could do the same thing with the second fraction and multiply top and bottom of the second fraction by the first fraction's denominator. So what do we get here? We have AD divided by BD divided by CB divided by DB. So in this case, I can use the commutative property of multiplication to rewrite this in one more step as AD over BD divided by CD divided by, and then I'm going to rewrite this so it's BD. Just to be clear here that BD and BD is the same number. So in my last step here, BD divided by DB divided by DB, or BD divided by BD is going to be 1, and I'm left with AD divided by CB, which would be AD over CB. And this would be a technique that some people might memorize. If I have A over B divided by C over D, I can take A over B times D over C. So I have AD over BC, which is the same thing here. So this flipping and multiplying really comes from finding that common denominator and then dividing that common denominator through. Your answer is going to be 1, and you're going to be left with this case. So if you go back up to Joshua's problem, you could definitely do it using Joshua's technique, or you could have 6/7 divided by 2/7 is going to be 6/7 times 7/2. This is where that common denominator step cancels out, and you get 6/2, which would be 3. In this case, you could find the common denominator in using Joshua's method and get the same answer, or you could have 2/7 times, really have 2/7 divided by 1/2. You could then flip the bottom denominator and multiply, and you would end up with 4/7, which would be the same answer as you would get using Joshua's method with the common denominator. So Joshua is absolutely right. He would have to do a little bit more work to get the answer in a case when you don't have a common denominator.